Hi, welcome everybody, and I hope you can hear this coming through your phone lines or over your PCs, as I would hope. So first of all, a big welcome to today's webinar. Okay, and so what I'm going to do is actually just launch right into, well, my introduction slide on my agenda, which should be coming up on your screens right now. So first, an introduction from myself. My name is Julian Hicks, and I'm a technical account manager at Arrow within the BI and Analytics Smart Center, and I'll be your host for today. But I'm not alone, because I have colleagues from both Splunk and Blue Coat who will be introducing themselves a little later as they do their parts of the presentation. Because everyone is in listen-only mode, if you wish to ask questions, please do so by submitting a chat response, and we will reply, either online, or if the question's a longer question, we don't have an immediate answer, we'll get back to you after the webinar is finished. If you perhaps leave some details as well, we can make sure that the right person gets the information. So firstly, I'd like to quickly recap what this webinar is about. So it's about, preventing cyber attacks is clearly a primary focus for any company, and it's a job that many of you in our audience today battle with on a daily basis. But when breaches occur, the security team must move quickly to verify the compromise and prevent malware propagation, but most importantly, block extraction of sensitive data. So today's webinar is going to showcase two key products that can be used to mitigate and manage security breaches. The products are Splunk Enterprise and Blue Coat Analytics, which when used together significantly speed up the time to resolution and give better context to the incident response teams. So before we launch into it, I just want to go back to our agenda for today and just point out some of those main points that you see on the screen. The Splunk product overview. There will be an introduction to the capabilities and value that Splunk Enterprise brings to any business, and you will see why it's become the leading operational intelligence platform. The Blue Coat product overview. There will be an introduction to the Blue Coat Security Analytics product, which is the leading product in that security space. And then we're going to have that hands-on demonstration, which I hope you're all looking forward to. It's really much the highlight of today, which is all about highlighting how effective the combined powers of Splunk and Blue Coat can be when investigating a security incident, and all managed from a single pane of glass. And then finally, at the end, we're going to have a call to action, which is simply a summary and point out some of those key useful links and things that can be valuable to you. You may also note that there should be a handout available to you from your Citrus webinar dashboard, which you can actually download, and that's a selection of all the slides, including the links and things that we'll have in the summation. So with that, I'm actually now going to lead into the Splunk product overview, and I'll let my next speaker introduce himself.
Hi, thanks Julia. Hi everybody, I'm Emanuele Pasqualucci, Channel Sales Engineer for Splunk. So let's see how Splunk can support your customer security teams. First of all, for these teams to properly investigate security incidents and identify threats, the modern challenge is to collect data that are not just the traditional security ones. So the challenge is to be able to collect data coming from non-traditional security sources like operating system logs, Active Directory, batch data, DNS. This is quite important to have all this data in a single repository to be able for the security team to monitor and correlate this information. This is really what Splunk lets you do. So the solution we're talking about is the platform for machine data, and Splunk can ingest any type of machine data from any source in real time with no parser and no connector. So it's able to collect both security and non-security related data. Once collected, these data are stored in a flat file data store with no schema or normalization, and will let the users search on this data. This opens a completely new world new world of analytics and business insight, because user can search through the data, be alerted in real time, aggregate data in seconds for custom reports and dashboards, so to be able to build advanced analytics. They can also develop custom content on top of Splunk by leveraging the REST API and the several SDKs that are available. In addition to that, Splunk is also able to ingest external data to enrich the machine data already collected from the different sources. This will let Splunk increase the accuracy and reduce false positives. We are talking about, in example, employee information from Active Directory, asset information from CMDBs, or blacklist of bad external IP addresses from third-party threats intelligence feeds. This is quite useful in order for the security teams to be able to connect the data pods and so to understand how the different data collected from the different layers can interact each other. So they will be able to connect the dot between the different systems and applications from which we are collecting security-related data and non-security-related data to identify the fingerprints of the modern threats. So Splunk offers different use cases. So the security intelligence platform and the Splunk capabilities can let you complement or replace existing SIEM deployments, while also address more complex security use cases, such as supporting fraud detection and finding insider threats. So by leveraging the power of analytics and visualization, our customers go well beyond the traditional SIEM use cases. Our platform, our offer in the security intelligence space is really one solution, but three offerings. So there is at the bottom Splunk Enterprise, that is our core product, and each Splunk deployment includes Splunk Enterprise, because this is where the core indexing and searching capabilities reside. Many customers then can build their own reports, dashboards, but they can also have the option to install apps on top of it. Apps are basically a collection of reports, dashboards, searches built for a specific use case or product. Can be built by Splunk, customers, partners, and there are the majority of them are free and are available on our Splunk base, our marketplace. So apps are a great way for customers to have out-of-box content. So for that, customers that don't want to build this content by themselves or want to extend point solutions. One of our key apps is the Splunk for Enterprise Security, that is the next generation SIEM, but there are over 200 security-centric free apps on Splunk base. So these are the three offerings, and includes the Splunk app for Blue Coat Security Analytics, which is in the red box. This app allows you to import the metadata through the Web Services API and alerts into your Splunk system. So this app has several dashboards to visualize the data, both from a network and threat information. The app also has a search page that is used to import, to pivot security analytics based on the fields in the resulting search. Several dashboards are available that are already configured to display the data from security analytics. So we have the web overview dashboard, network overview dashboard, as well as the threat views. The app also includes an event workflow action that will let you pivot in security analytics. But I will let at this point Andrew Shepard from Blue Coat describe the Blue Coat security analytics solution.
Great. Thank you, Manuel. So my name is Andy Shepard. I am the sales engineer for Blue Coat, covering the APT portfolio, which is obviously today covering security analytics. So just to make a nice clear difference here about basically the two different technologies. So while Splunk is collecting machine data and very much a log-based solution collecting from across the network, security analytics is a different approach. So what we're recording is raw packets from the wire, whether that's TCP, UDP. We're looking at layer 2 to layer 7. We're recording every single protocol as it happened on the wire at the time. So this isn't process data. This isn't the opinion of application. This is the packet as it existed. There's no user agents, no configs. We plug it into a tap and we start recording. So whether we're looking at the content of a file, maybe the actual PDF that was on the wire at the time, or maybe an actual an image or a JPEG that was come down, or whether it's leaked content, or maybe something, and it's a cheesy example, but things like Hotbleed, maybe where there wasn't a log. Security analytics is like a net just catching absolutely everything as it happened. So with that, we're able to actually replay traffic as it existed. So if there was a single network session a day ago, a week ago, we can pull that from the disk and analyze it as it happened back on the day. Obviously, we have intelligence built in like all other security tools, and this is the kind of intel that we also mark things of interest, and we can also push that to Splunk as well to be another submitter of machine data into it. Now, typically, or should I say, a basic usage of security analytics is either using the tool, or maybe even pivoting in from one tool, so an IPS or a firewall. But the demo we're talking about here today is if we can pivot in from Splunk, just imagine how many different tools on the network there are that are building that machine data, that cumulative intelligence that we can then pivot to security analytics with. So as well as giving the context to a network stream or a bit of network traffic, we're able to apply that from the Splunk collection and center intelligence to now apply to basically any tool. I think that's where these two systems play very well together. Is as Julian's mentioned, when we have this single pane of glass dashboard, this existing place for intelligence, pivoting from pretty much anything in security analytics to expand on the context and maybe show the actual packets at the time is where it becomes even more powerful. So why is that important? So we often talk with security analytics about the context. So logs will say what's happening. They may say which systems are detected or which users logged on. But if we can start to replay the traffic, we may be able to start to answer a few more questions. So by looking at the attack in more detail or replaying, exactly what PDF was leaked rather than just say the name of the file, we may be able to work out who the parties involved, who was doing it. We can look at other traffic that say maybe an IPS flags one packet, one frame of data, but what else was happening at the same time that maybe an IPS didn't know about, that maybe a firewall didn't know was of concern. So being able to replay the real-time traffic from that small segment of time and from that one machine helps answer a few more questions, the fuller context of who, why, what, where. And in many cases, can it happen again? So by understanding where the defenses may have had small holes in, we can start to replay that traffic through other sources and see, are our signatures now up to date? Are they now blocking the attack that we retrospectively found from maybe an hour ago, maybe a day ago, maybe a week ago? So with that, I'm just going to take control and just give a very brief recap of the interface. So as we can see here, this is the high-level dashboard of security analytics. And like many tools, it's using a web user interface, and we have the widgets and we have the metadata. So obviously, whilst our strength is this recording of traffic, whether it's a megabyte, a terabyte, a petabyte, we still have that metadata to pivot on to pull the data out. So in this little session I have here, we have 27 megabytes of data and 50,000 packets that are observed on the wire. We can see the applications, we can see the web servers, the countries, file hashes, file types, and many more attributes. What we're looking at here is a very simple high-level screen with just a few of the attributes that we can offer. And with a few clicks, for example, if we picked on a country at random, let's say France, with a few clicks, we're now reanalyzing that same time window, the same amount of traffic, but instead of 27 megabytes, we very quickly found 50 kilobytes of traffic. instead of 50,000 packets, 20,000 packets, it's 400 packets. So that ability to zoom in, and if we do it one more time, we can see here that with a little bit of interest in just a few clicks, we've zoomed in from all those packets down to 56. And that's the ability of zooming in. When that question can be identified, what do you want to look at? So if that's Splunk correlating different data from all the different sources across the network, maybe if we have, say, 5 security tools complaining about one source IP, that might mean it's starting to eliminate things like smaller false positives because every tool is agreeing that this is something that needs looking at. We're then pivoting it from Splunk, this single pane of glass, straight to packets, where within a few clicks we found the actual PCAP of data containing the PDF or the executable that causes the issue. So with the dashboard covered, I'm just going to change it back to Julian for the next slide. Okay, so just a 30-second overview of the demonstration we're about to give. So, like I say, an oversimplified network diagram. We have an endpoint agent with antivirus installed. The traffic would flow through a tap, through an IPS, through a proxy, through a firewall, and off to the internet. So when we start to see the data, whether that's malicious or good, any type of data, what we'll see is as the packet goes out to the internet, we're getting a collection of the raw packets to security analytics, but also we're getting logs from across the entire estate into Splunk. So Splunk is this compilation of reports, this machine data across the enterprise, and then security analytics recording, say, just the raw packets. So very much different architecture and different approaches, but we're going to see how we can use those two together to get to the bottom of an incident where we've seen different tools reporting about it. So with that described, I'm just going to pass the control over to Emanuele.
So here we have an intrusion center dashboard. What we have done is to provide that single pane of glass that Andrew was talking about. So we have different data sources, different charts to show, to be able to observe the same data set from different perspectives. So this intrusion center provides an overview of all the network intrusion events from different devices like IDSs, IPSs. In addition to that, we have also some antivirus data, firewall data. So we were talking previously about the capability of Splunk to index different data sources from different formats in real time. So this dashboard shows the attacks over time by severity, the top attacks by count and signature, as well as the attacks that have been identified for the first time. That means these vectors could indicate a change that has occurred on the network, or potentially due to the presence of a new threat, such as a malware infection. This is a dashboard, so is an active report that we can browse this data, we can click on this data, and really the behavior of the click is can be configurable. The dashboard as well can be easily modified through the user interface. So let's say we want to investigate a specific incident like the DNS info blacklist. We drill down to the raw events. So Splunk is collecting the raw events. This is our search toolbar, and this is an example of a query that you can write in our search and processing language. So quite easy. We could change the keywords in order to investigate further, or we can change the time range in order to be able to check if the same events, the same incident occurred in the past, in example. These events are then represented on an histogram, so to be able for you to understand immediately if there was any anomalies in your events. This is a Google-style search. These are the raw events, as you can see, collected from the different data sources, And this is the knowledge on the left that Splunk is adding to the data. So the raw data are not are stored as they were in their original format, and Splunk is adding during the search time the knowledge, so to be able for you to better understand what's inside your data. An example is the source IP field, from which we can see which are the different IPs, the source IPs from which we are getting the DNS blocklist event. So if we want to investigate a specific IP, it's just needed to click on the value, and then we are narrowing the events, the search to just few events that include that source IP. This is very useful to start investigating this kind of issues. As part of the workflow, the option to include an event action, so we can interact between the different dashboards, the different tabs in Splunk, so to build our own investigation flow. So we want now to take a look at this host from the Blue Coat Security Analytics app, because we want to really understand what's going on on this host, so to understand if there is any other issue that we may want to investigate. This is one of the few dashboards included and views included in the Security Analytics app. So we have the network overview, the web overview, as well as different views for threats. As you can see, this is a form, so the user doesn't have to interact with our search language, but needs just to specify to include few filters. In this example, the source IP and the destination port were already passed from the previous click. So now we have a complete network overview of what's going on this host, and we may want to investigate the different data collected for this host on the DNS application. Again, we are drilling down the raw events, and we can see the different format, and we can immediately see that there is something very strange in our data. So the domain names seems quite strange, and we may want to decide to investigate further and to open the Security Analytics console in order to find the root cause of this security issue.
Brilliant. Thank you, Manuele. I'm just going to take over now. So we're moving to a different browser, but it's the same data set in the back end. So just to kind of really recover that point as before. So, whether Security Analytics has recorded a megabyte of data, a terabyte of data, or a petabyte of data from one office, from 1,000 offices, from 20 data centers, from whatever kind of deployment we have, because we've come in from Splunk, because Splunk helped maybe identify a question or raise the alerts that have been happening. What we've done with the link, we've copied across the date, we've copied across the time, the IP address, and for example the port number. So whilst we have a petabyte of data, what we've done here is we've zoomed in straight away to the 64 kilobytes of interest, these 702 packets. And what we can see now, in this session and related to this session that caused the alert, we can see a lot of DNS, so biz.org.ru.ms. We can see a country, so some traffic going to America. Now, when we talk about full context, it's about looking at a slightly bigger picture, or just looking maybe to the side where an IPS didn't trigger, or maybe where a proxy didn't have an opinion on a URL. So what I'm going to do is I'm going to remove one of these attributes in the top left that Splunk carried over for us. So we're still looking at the same window of a few minutes from this morning, from yesterday, from a week or a month ago. And in that 5-minute window, we're still looking at the same source IP address. So what else was happening at the time? Well, if we look in the middle left, we can see some web traffic, some DNS. We can see some DHCP and some certificate traffic. We can see, as well as the DNS queries, we did actually talk to the servers. We can see file names, we can see file types and hashes, just as we looked at before. Now, as an analyst, maybe looking at, again, the bigger picture, looking out for things that are a little bit odd, just by looking at this 5-minute window and nothing else, on the right-hand side, I can see 560 requests to count13.php. So I'm going to filter on that. So we're pivoting on the same time frame, the same internal machine, but we can see that of these 560 requests, straight away, we're seeing, those web servers of .biz, .ru, .org have quickly fallen away, and all these other DNS requests have bubbled to the top. So whilst the IPS was picking up a few of them, we're seeing that there were a lot more in the same breach, the same set of events. We can see the countries. So if we pick, for example, we picked France last time. So if we pick, say, Romania, we can filter into all the traffic that went to Romania against those domains. It could be that we look at, for example, the specific web server. So show me where we went to that file on this web server. And if we click that, we can see that associated with this session, there was also a PDF downloaded, and we've already have that hash stored. So if we can't retrieve that PDF from a web server tomorrow, at least we know the hash of the file in Meta, but we're also going to have the full PDF to analyze later on. Now, we can click back and forth for a while and pivot on different countries or different usernames, different network segments. But at some point, we're going to realize that we want to look beyond metadata. We want to pull out that raw data, that PCAP, as I've mentioned earlier. So if we look at all these requests of count13.php, we're going to go to the second screen that I want to show you today. So in the top left, I'm going to click on the Extractions tab. So instead of saying how many were there, instead of reports or a summarization, we're starting to see here the actual requests that happened in the packets a day ago or a week ago. So if I expand this one halfway down, I don't know if you can read it on your screens, but we can start to see things like port numbers, IP addresses. Now, what kind of traffic did we detect in this stream? It could be that we've been presented HTML, but we have actually detected something different. We have hashes, we have file names, and we have a few more tools here we're going to go through in a second. Now, all this metadata is being pulled out and presented against each of the objects that we see. So we very quickly see why was that file requested, where did it come from. If we look down on the left, we can see that the time frame is happening too quick for a user to type. So this very much looks like some kind of beaconing to all these random domains that are being computer generated. So something fishy is definitely going on. So again, we're going to slightly expand the query to things that maybe didn't trigger an alert, but things that are just as important. So by removing the attribute in the top left again, this count13.php, we can see that just a second before this beaconing started, this scraping, with hundreds of requests to remote sites, we can see a request to a website called seatoandYouthShelters.org. Now, because we recorded the packets as they existed, we're not going to say, what does the website look like today? What does the website look like if I requested it now? We're actually going to rebuild it from disk, and we can draw it the way the user saw. And this is what the user saw, a blank page. So you could forgive a user for thinking, well, this is innocent, it's not interesting, I'll click away. But actually, we're going to reconstruct the code of that page from the packet. So as we look here, some very heavily obfuscated JavaScript. And as you will know, that is not a blank page, that is not an innocent dead page. So how did we get to Seat and Youth Shelters? Well, if we look a few links above, we can see this request to google.com, where the query was Seat and Youth Shelters. So let's rebuild this. If we enable images, this is the page as drawn at the time for the end user. So we can see a Google search for a relatively innocent looking domain. We can see the results that came back, so we can see exactly where the eye would have been looking, or what kind of things that the user was finding, whether this is on Google or a different page, or so on and so on. So when we talk about adding context, this is what we're doing. Rather than just saying we know an IPS flagged this, or a proxy flagged that, Splunk has told us that all these different events kicking off together, we've gone to the actual packets that created it, and we're starting to have context of, well, we know why they went there because we can see what they were doing. An innocent search that led to a malicious website. But let's start to look after these alerts were triggered. What else was happening? So on the left-hand side, I'm going to apply a further filter. And the one I want to do today is file type. And what we've done is we've summarized every file visible on the network at the time. So we can see some Java files, some certificate transfers, a DOS executable, a zip file, and 3 PDFs, which, funnily enough, relates back to what we saw at the beginning of this half of the demo. So we can see that in this time frame, for that machine, 3 PDFs came down, and the first one from inzx.org. We can see the hashes again. We can see the IPs. Where did the domain point to a week ago? Or rather than where does the DNS point to today, or does the web server exist? We can pull this PDF down. So instead of doing the preview, we could download just the item or the entire PCAP, and this may let us replay it through an IDS to check the latest signatures. We could replay it through a different malware tool or some kind of manual investigation because we have the actual packets. And the last little tool I want to run through today is the Explore Root Cause. By clicking on that, what we're doing is, because we recorded the referrers and the iframes and the 301s and the 302s, we can see this PDF at the bottom with all its attributes, but then we look back and say, well, which request did that come from? Where does that referral point? That brings us to the third one down. Where did that one come from? The second one, and where did that one come from? And at the top, we can see the host at Seaton Youth Shelters. So we're very quickly tying up this story. Now, we could pull the PDF and do manual investigation on it. I'm sure all the, a lot of the tools that have been reporting to Splunk would have also had an opinion. Within one click, we can start to view, maybe external source of information. So in this case, we know it was a known bad file. So, if the IPS hadn't have flagged it to Splunk, maybe the proxy hadn't have flagged it, we would have done. It would have bubbled up in, that single pane of glass and those centralized dashboards, allowing us to very quickly pivot back to it and build out the story of the context. So with all that being said, that wraps up the technical side of the demo. I just want to share one further slide on Julian's desktop. So I'm just handing the control back. So why have we done this demo of showing the two technologies linking between each other? Well, it comes down to the questions. Where Splunk is fantastic at bringing together the known alerts, with tools across the estate, whether that's firewalls, proxies, IPS, making intelligence out of them. Maybe saying, look, this one IP address is flagged across the network. We're able to answer some slightly different questions here. Now we're starting to maybe replay the attack and see the images. So whether that's who did it to us, how did they gain access, maybe even what data was stolen, which is obviously especially relevant with the latest GDPR stories. Have you contained it, and can we stop it happening again? As we can replay traffic and events through known signatures and known tools, we'll be able to make sure the defenses are tuned against maybe the next wave that would come tomorrow and block those holes. So with that over, I'm going to pass back to Julian for the next slide.
Okay, well, ladies and gentlemen, on the other end of the phone lines, I hope that was enjoyable for you. So what I'm going to do now is just quickly summarize and then, well, really point out the call to action. So basically, in summary, what we've seen today is a journey. A journey where we've used Splunk to capture events because Splunk's so great at managing that complete infrastructure. Looking at that operational intelligence information and really deriving value from it. And we've taken that Splunk information and we've combined it with what Blue Coat security analytics product can do, which is all about taking us right down to that deep dive, that root cause analysis. So really the combined products are absolutely fantastic in this whole space of security analysis and investigation. So with that said, next steps. Feedback and interest. Obviously, we will be in touch with you, but importantly, I hope you've enjoyed today and want to be in touch with us. Okay, and on the next slide there will be some contact addresses and things you can get to us, but also hopefully you've downloaded the slides. All the information is in there. Naturally, we'd like to follow up with a meeting and make available trial licenses so you can actually get your hands on this stuff. Give it a go, try it, see the value to your business. We're also planning a half-day technical workshop currently lined up for the 18th of February. So once again, hopefully you'll be interested, want to be involved in that, and please contact us and we can arrange that to happen with you. Naturally, there's some links to resources. Those are on the screen. Again, part of the handout. So with that, I shall just go to my final page and wish you a big thank you for joining and end the webinar there. Have a good day. Bye.